Okay, a little bit more of a close-up on the LKZG unit. LKZG is really an acronym for Radio Beam Autopilot Interface Unit. And there's three important parts I want to point out to you. First of all is this drum system. This drum system, one part is driven by the course motor. The second part is more or less stationary. I'll come back to this part a little bit later. There are a number of contacts on one drum which touch on a series of contacts and potentiometers inside this drum. If the two drums are aligned, the potentiometer is aligned and gives a zero output. If this drum turns left or right, the potentiometer will give a positive or a negative proportional output, which goes to the second part, which is the relay here. The relay consists of two round bits here, which are basically the internals of very sensitive ampere instruments. Yeah, so indicating instruments. They took the needles off and they linked these two instruments. There's a very small little needle which touches some contacts here, which drive this relay. So as this potentiometer is generating an output, it will create a turning force which will drive this little relay left or right. Now, the potentiometer is not the only thing that provides an input. The other instrument here is connected to the radio, the FOG25 beam radio, and that gives another input. So basically it's the sum of these two instruments, they're basically fighting each other, that determines the direction in which this relay is set. I'll switch this on and see if you can see it work. You will now see that the relay has turned to one side, and the sound that you hear now is the course motor turning the drum and the autopilot towards the beam. It will do that until it reaches an equality between the radio signal and the signal from the drum. So this keeps turning until this instrument returns to zero, which is now, and now it's actually starting to turn in the other direction. So now the aircraft has flown towards the beam and now it's curving back parallel to the beam. It's flying an S-curve. Now it's reached equality, and you can see it starts to pulse now as very slowly we approach the beam. The radio signal is getting weaker, and the system is trying to bring the potentiometer back to its original position. The other noise you hear now, and the little movement you see here, is that of the automatic drift compensation. There's some contacts in these drums that drive a little motor here, and it actually turns this drum very slowly right or left. So if the aircraft reaches the beam, so 0 degrees, while still at a slight angle, it probably means that the wind is blowing it slightly off the beam, and this Nachstellmotor, or this wind compensation system, automatically makes sure that the aircraft starts flying a slight love angle to the beam, and that it stays on the beam automatically. So basically now the aircraft has almost flown its S-curve. The Nachstellmotor is doing its work by really slightly changing the set point until it finds the stable 0 point of the beam. So here's really how the LKZG functions. Thank you.